Today we're going to learn about graphing piecewise-defined functions and shifting and reflecting graphs of functions. And these are the objectives for today. A piecewise-defined function. It's defined by two or more expressions. Notice that this expression is used if the value we choose for x is less than or equal to 0, and this is the expression we use if the value we choose for x is greater than 0. So it all depends on the value for x as to which expression we will use. But let's graph each piece separately. So let's start with the value that's less than or equal to 0. One of our choices that we're going to choose for x is going to be 0, because that's where our starting point is. So we put a 0, and we substitute it in for x. 3 times 0 is 0, minus 1 is negative 1. Of course, that's going to be a closed circle. Let's choose another value less than 0. 3 times negative 1 is negative 3, minus 1 is negative 4. So you see what you do? You just pick values for x that will satisfy this value for x, and then we discover what our y value would be. So now we've picked values less than or equal to 0. Now let's pick values greater than 0. So if we choose 1, we substitute a 1 in for x. 1 plus 3 is 4. If we choose 2, we get 5. And 3 plus 3 is 6. Now we're going to graph these first 3 points. Notice we have a closed circle because it's or equal to, and it doesn't have an arrow going this direction because this is the smallest value it can have, or the largest value it could have. And then we continue on. Now let's graph the second expression. If you were to put in a 0 here, you'd know it graphs at 3. So there's an open circle at 0, 3. And then our other points. And notice open circle, and it continues on. There are vertical shifts, and you can find some more information on vertical shifts on, let's see, is that page 180? 181. Notice that this part, the K, is not inside the grouping symbol. So that lets you know it's a vertical shift, and if it's plus, it goes up. If it's minus, it goes down. Very simple, right? Now, horizontal shifts are a little bit different. Look how it's in a grouping symbol. H is in the grouping symbol. You normally think of minus as going to the left, negative to the left, but because it's in parentheses, it's going to move to the right. So it's opposite of what you think when it's inside the grouping symbol. So vertical shifts are not in a grouping symbol. Horizontal shifts are in a grouping symbol, and they go the opposite direction than what you would think. So if there's a plus in there, it goes to the left. If there's a minus, it goes to the right. What we begin with is the parent function, and there are pictures of some common functions on page 180 of your textbook, if that would help you. Our parent function would be just x squared, so we're going to begin with the graph f of x is equal to x squared. Now you'd have to choose a table of values, again, in order to plot these points. Now this is not in a grouping symbol, so we know that we're going to take this graph and we're going to move it down 3 units. 1, 2, 3. So it goes down 3 units and it continues on. What's the parent function for this one? It's the absolute value of x. So you know it's going to have a V-shaped, right? Notice that this plus 2 is inside the grouping symbol. So that means it's going to go left or right. Well, it's a plus. We normally think plus goes right, but it's inside the grouping symbol, so it's going to go 2 to the left. And then finally reflections, and you can find more on reflections on page 182. The graph of g of x is equal to the opposite of f of x. So is the graph of, it is reflected across the x-axis. So let's look at this reflection. Notice this is the opposite of the square root of x. We're going to begin with the graph of the square root of x. If it's reflected across the x-axis, here's the x-axis. So just like it was a mirror, it's going to be going the other direction. See how that works? All right. So now it's time for you to begin practice on your own.